Hi everyone, this is Ruth and welcome back to my channel. This channel is mainly about my home lab where I build different setups, test networking tools, and experiment with infrastructure projects. My main goal with this lab is to practice cybersecurity skills in a real environment. So over time, I'll be building out different systems, security tools, and monitoring platforms. In this video, we'll configure VLAN firewall rules in pfSense. We'll begin by creating an alias for internal networks. Then, configure the admin VLAN followed by user VLANs such as HR, sales, and others, ensuring they are properly isolated from internal networks. First, we create an alias to represent all private internal networks. This simplifies rule creation and improves readability. Navigate to Firewall, then Aliases, select the IP tab, click Add. In the name field, enter like RFC1918_networks. Set the type to network. Under networks, add the following entries. First, write 10.0.0.0/8. For the description, write private class A. Next, 172.16.0.0/12. For the description, write private class B. Then the last one is 192.168.0.0/16. And for the description, write private class C. Click Save, click Apply Changes. We'll begin configuring rules in the admin VLAN interface. Navigate to Firewall, then Rules, then go to Opt1 tab. First, we allow DNS traffic. This enables devices in the admin VLAN to resolve domain names. To add the rule, click Add, set action to pass, confirm interface is Opt1 or VLAN or admin VLAN. Set address family to IPv4, set protocol to TCP/UDP. In the source section, choose Opt1 subnets. In the destination section, select this firewall. Scroll to destination port range, set from to DNS53, set to DNS53. In the description field, enter allow DNS to pfSense. Click Save and then click Apply Changes. The destination is set to this firewall because pfSense is acting as the DNS resolver. Next, we allow access to the pfSense web interface. Click Add again, set action to pass, confirm interface is Opt1, set address family to IPv4, and then set protocol to TCP. In the source section, select Opt1 subnet. In the destination section, select Opt1 address. Scroll to destination port range, set from to HTTPS or port 443. Set to HTTPS or port 443. In description, enter allow web GUI from admin VLAN. Click Save and Apply Changes. This ensures only admin VLAN devices can access the firewall interface. Now, we allow ICMP traffic for network diagnostics. Click Add, set action to pass, confirm interface is Opt1, set address family to IPv4. Now set protocol to ICMP, leave ICMP type as any. In the source section, select Opt1 subnet. In the destination section, select single host or alias. Enter RFC1918_networks. In description, enter allow ICMP for diagnostics, and then click Save and Apply Changes. This allows administrators to test connectivity to internal networks. Finally, we block direct access to internal networks. To add this rule, click Add again, set action to block, confirm interface is Opt1, set address family to IPv4, and then set protocol to any. In the source section, select Opt1 subnets, and the destination, select single host or alias, and then enter RFC1918_networks again, and in the description, enter block admin access to internal networks. Click Save and Apply Changes. The admin VLAN is now configured. Next, we'll apply similar rules to the user VLAN with stricter isolation. First, we allow DNS traffic for the user VLAN. Go to Firewall, and then Rules, and then go to O2, which is our VLAN 30, which is intended for the sales department. So now let's click Add, set action to pass, set address family to IPv4, set protocol to TCP/UDP. In the source section, select up to subnets. In the destination section, select this firewall. Set the destination port to 53. Enter in the description allowed in S2 pfSense, and then click Save and apply changes. Next, we block ICMP traffic to the admin VLAN. To add this rule, click Add again, set action to block, set protocol to ICMP. In the source section, select up to subnets. In the destination section, select opt1 subnets. In the description, enter block ping to admin VLAN, and then click Save and apply changes. Now, we block access to all internal networks. Click Add again, set action to block, set protocol to any, and in the source, select up to subnets. In the destination, enter the RFC 1918 underscore networks. In the description, enter block VLAN to internal networks. Click Save and apply changes. Finally, we allow internet access. So let's click Add again, set action to pass, set protocol to any, and then for the source, let's select up to subnets again, and then for the destination, set it to any. For the description, enter allow internet access, and then click Save and apply changes. Repeat this process for each additional VLAN interface, such as HR, user, and DMZ. Make sure the source network matches the VLAN you are configuring. For example, use opt3 subnet for the HR VLAN, opt4 subnet for the user VLAN, and opt5 subnet for the DMZ. Once completed, all user VLANs will have internet access while still being restricted from internal network based on the earlier rules. Now that all rules are in place, we'll perform a series of tests to verify connectivity and isolation across all VLANs. First, we test communication between user VLANs. Each user VLAN should be isolated from the others. Now, let's log into a virtual machine in VLAN 30, which is a sales VLAN. And then open PowerShell, and then let's identify the IP of a virtual machine in another user VLAN. For example, VLAN 40, which is the HR VLAN, has IP of 10.0.40.100. And then in the VLAN 30, let's run ping 10.0.40.100. The request fails, confirming that user VLANs cannot communicate with each other. Next, test connectivity from a sales VLAN to the admin VLAN. This should also be blocked to maintain security. First, let's identify the admin VLAN IP address, which has 10.0.10.100. From the same virtual machine in VLAN 30, run ping 10.0.10.100. This confirms that user VLANs cannot reach the admin VLAN. Now, let's test from the admin VLAN. It should have visibility into all VLANs for monitoring and diagnostics. Open a PowerShell into the virtual machine in admin VLAN, which is the VLAN 10, and then verify IP address. And let's identify IP addresses in other virtual machines that assigned to the other VLANs. So for VLAN 30, which is the sales VLAN, it has IP address of 10.0.13.100. For the VLAN 40, which is the HR VLANs, so the virtual machine has IP address of 10.0.40.100. For the VLAN 50, which is the user, it has the IP address of 10.0.50.100. For the virtual machine of VLAN 60, which is the DMZ, the VM has IP address of 10.0.60.100. Run ping commands to each IP addresses. The admin VLAN can reach all user VLANs for diagnostic purposes, but note that it does not have unrestricted access to internal networks due to the block rules. Next, we check that the admin VLAN cannot access the internet, keeping the management network secure. So, from the admin VLAN virtual machine, open a web browser and attempt to load a public website like, let's say, youtube.com. Or we can ping public IP address too. Internet access is blocked for the admin VLAN as designed. This protects the management network. Finally, ensure that the admin VLAN can still reach the pfSense firewall for management. From the admin VLAN virtual machine, open a web browser, navigate to the pfSense web GUI. The admin VLAN can access pfSense for management, confirming that administrative tasks can be performed securely. Now, let's verify that each user VLANs can access the internet. Let's use the VLAN 40 virtual machine, which is the HR VLAN, and open a web browser and navigate to a public website like google.com. Optionally, you can ping the public IP address too. Each VLAN can access the internet while remaining isolated from other VLANs and the admin VLAN. Repeat all the tests for each VLAN to confirm proper isolation and functionality across the network. That concludes our walkthrough of configuring VLAN firewall rules in pfSense. With this setup, the admin VLAN provides controlled visibility while user VLANs are properly segmented and secure. This is part of my Homelab setup to enhance my cybersecurity skills using real-world networking practices to build a safe and organized environment. Thank you for watching. If you found this video helpful, be sure to like, subscribe, and hit the bell to follow along as I continue exploring networking and cybersecurity in my home lab.